While we consider stars, we most likely envision small, sparkly things in the evening sky. Basically, this is the manner by which we see them from down here in the world. Yet stars are something totally different, little in reality. Quite possibly of the greatest star, Betelgeuse is a lot bigger than our sun. For a really long time, this star has confounded researchers. However, as of late, another element disrupting has been going on with Betelgeuse, making researchers and other well-informed people extremely concerned. Join us in this video as we investigate the dynamite news about Betelgeuse, its approaching obliteration true to form by the James Net Telescope, and how this new improvement will influence our universe and our lives here in the world, as made sense of by physicist Michio Kaku. Betelgeuse is a vast miracle, an enormous star that has interested cosmologists for so lengthy. A Greek stargazer named Tony was quick to discover it. This star is huge to the point that it very well may be found in the night sky from Earth, particularly during winter. If you're into groups of stars, you've likely seen or heard about this star. It is the rosy-orange star that denotes the upper left shoulder of the Orion group of stars. So, you see, this star is antiquated and thus far, quite possibly, of the most brilliant star in the evening sky. However, one thing about Betelgeuse's brilliance is that it doesn't remain consistent. Rather, it varies. This change is one of the exceptional properties of this star. But it isn't just a single. We should check out at some of Betelgeuse's explicit properties. A large portion of the stars you find in the night sky are a long way from Earth. The closest star is 4.2 light-years from Earth. If you don't see how the term light-years makes sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It's been demonstrated that light can cover a distance of 186,000 miles per second. Thus, the distance light can cover in a year is equivalent to 1 light-year. Assuming you figure it out, you'll have billions of miles. So when we say the nearest star is 4.2 light-years away, it implies it is billions of miles from Earth. But guess what? A few stars are even farther, and Betelgeuse is one of them. Betelgeuse is found approximately 600 light-years from Earth. So, if you were to venture out to it at the speed of light, it would still require 600 years. We can't move that quickly. Not even our quickest space apparatus can. However, this star can still shine so bright in our sky. If you're considering how Betelgeuse can be so brilliant notwithstanding its distance, that is because of its different characteristics like size and brightness. Betelgeuse is around 500 times bigger than our Sun. Its radius is believed to be multiple times that of the Sun. Unfortunately, it shows up as a disk in space while utilizing refined telescopes, while different stars show up as little marks of light. The disk appearance is thought to be an impact of the reactions at the outer layers of its atmosphere. When it comes to mass, Betelgeuse measures around 12 to 19 solar masses. A solar mass is the standard unit of mass utilized by astronomers. One solar mass is equivalent to 2 by 10 to the power of 30 kilograms. Scientists can't determine the exact mass of Betelgeuse since there are no other planetary bodies circling around it to compare with. Of course, we can't measure it directly from here, but it is known that this star is no less than multiple times heavier than our Sun. The brilliance of Betelgeuse goes from around 0 to plus 1.6 in more natural terms. Betelgeuse is multiple times more brilliant than our Sun. No wonder it was nicknamed a red giant. However, the brilliance of Betelgeuse doesn't remain consistent. It varies. This change is due to its throbs. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it darkens. This interaction can last for 10 to 100 days or even much more. One extraordinary property of Betelgeuse is that its surface is covered in dark, magnetic spots. The magnetic field in these regions is far stronger than at the normal surface. But the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has bunches of these spots compared to our Sun makes sense of why it is cooler than our Sun, notwithstanding its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are a lot larger and much more numerous. To give you an idea, the spots on Betelgeuse can be 2 times as extensive as the Earth. Betelgeuse also boasts a magnetic field that is multiple times stronger than that of the Sun. This field is the reason when seen through a telescope, The gases on the outer layer of Betelgeuse seem to be in circles or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature adds to the low energy radiated by the star and its faint red variety. Betelgeuse is a red star, but it wasn't always red. It was yellowish around 2 million years back, just like our Sun. Over the years, the variety started changing to orange-red, and then around 2,000 years ago, it slowly started becoming the red star we know today. This fact has made researchers believe that the star is aging. Betelgeuse emits as much as multiple times more energy than the Sun. It would have been a wild opponent to Earth's Sun if it weren't really far away. Despite the fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the unaided eye at night, it is quite wonderful. Our Sun is only 8.3 light-minutes from Earth. That's why it's so visible. If Betelgeuse were just a bit closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would gobble up or displace the Earth and the other 4 planets near it because of its huge size. Besides, even if it could match, it produces more radiation than our Sun. Betelgeuse, also known as Betelgeuse, is a very giant star located in the constellation Orion, roughly 600 light-years from Earth. Its immense size is one of its most striking features. It is multiple times larger than our Sun concerning radius and could easily incorporate the orbit of Jupiter if put at the center of our planetary system. This epic size allows Betelgeuse to appear as a distinct disk instead of a point of light when seen through powerful telescopes. In contrast to most other stars, despite its gigantic size, Betelgeuse isn't the most massive star. It ranges in mass from around 12 to multiple times that of our Sun. This variation in mass estimation is due to the challenges in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nevertheless, even at its lower estimated mass, Betelgeuse remains a huge celestial entity. The brilliance of Betelgeuse is another important characteristic. It varies unpredictably over time, with its brilliance ranging from 0 to plus 1.6. For comparison, a size 0 star is around 2.5 times brighter than a size plus 1 star. At its brightest, Betelgeuse can be multiple times brighter than our Sun. This variability is attributed to its throbs, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These throbs can last for days to months, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct reddish-orange tone, typical of red giant stars approaching the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution where it has depleted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical peculiarities. It displays dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our Sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper inside the star to its surface, contributing to cooler spots on the star's surface. Betelgeuse's history and cultural significance also make it a prominent celestial object. Known since ancient times, Betelgeuse has been observed and documented by various civilizations over the course of time. Its visibility in the night sky, particularly during winter in the northern hemisphere, has made it a prominent feature in constellations and mythology. Recently, Betelgeuse has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into mid-2021. During these periods, the star's brightness dropped to extreme levels, sparking speculation among astronomers about its impending fate. While such dimming events are not uncommon for variable stars like Betelgeuse, the extent and duration of these episodes prompted discussions about the possibility of Betelgeuse undergoing a supernova event in the relatively near future. Supernovae are catastrophic events that occur when massive stars reach the end of their life cycles and undergo rapid collapse and explosion. A supernova blast releases a tremendous amount of energy.